All right, so let's start, and let me make sure that everyone that is supposed to be here, in fact, is here. And hold on just a second. And let's see. Anyways, all right. Um, so I'm hoping everyone is doing well today, and we went over a few things. We went over the control flows, and first we went over things like greater than, if then. So we went over logical operators and everything. So let's just do a little review. The first major new concept we went over is the what we call the ternary operator. Okay, and so we can see that we have this situation in which you have either low or upper. So we can define the income level, and we have initialized class name, and we're saying if income is over a certain point, you can call yourself upper. The class name is upper. We can see why we didn't declare it right here. We simply initialized it. So if the income is over a certain amount, we can declare it as upper, or else it is lower. But we made the better choice here, in which we not only initialized it but declared it as lower here. And then we said if the income is over a certain point, we declared it an upper. So this saves a statement or two, and it makes it look a bit more elegant. But the ternary operator makes it a little bit better, because here we can say income greater than 100,000. So we can make a positive statement. So we can make as they say, we can make a logical operator statement. Okay, and of course the output of a logical operator is either true or false. So the output of this is true, but here we cast it. Okay, we kind of cast it as a string because we're using the parentheses right here, and it is next to this. Now the ternary operator essentially is the question mark. So the question mark does the logic, and the logic says, okay, the outcome or the return value of this operator is going to be a type string, which is why the type string here exists. And we're casting it as a string, as you can see from the parenthesis. And the resultant is going to be the truth value of whatever this is. If it's true, it's the leftmost value, which is upper. And if it is false, it is the rightmost value, which in this case is lower. Okay, then we went over the switch statement, in which you can see it is a little bit more elegant looking than a typical if-else statement. So this is if, else, if, and then else. So we can see the switch statement is a little bit more elegant looking here. Here we define role as a string value, and we declare it as an admin, and we say case admin, case user, and default is kind of like the umbrella, if you will. That is the catch-all in case neither of the first two options fulfill the role inquisition. And here we have it in terms of an integer. So we have role equals 2. In case 1, it says hello admin. Case 2, hello user. And anything else, it says hello guest. In this case, the result would be hello user. And now we enter into the idea of the for loop. Now, the for loop might be in a response to this being so inefficient. So with the for loop, we use the SDI concept in which we define the source or starting. We define the end condition. So here we start off with I is equal to 0. It should be lowercase I, lowercase I equals 0. And then I less than 7. So we start off with I being 0. And it will continue until I is less than 7. And the step or increment it will take will be adding 1 to the I. Because if we didn't add the 1 to the I, guess what would happen? It would yield an endless loop. So the stepwise here prevents the endless loop. So what the for loop actually does, it allows us to walk through an iterative set of numbers or a situation. It allows us to step through, but it's a controlled amount. Okay, so we start off with just saying hello world like 6 times, but if we want a more efficient way of doing it, we can use a for loop, because we can say for, this is the starting point, I equals 0, and then until I is less than 7, it will keep printing hello world. So under this, without the increment, it would actually go in perpetuity. But because there's an increment, it will take the I and add 1, as we can see here, and it will add I by 1, so we have 0, 1, 2, 3, 4, 5, and it stops at 6. And we can do the same thing if we decrement I. So in this case, if we said I is equal to 7, and we said y, and then we can say until I is like equals 0, and because I will never equal 0, it will go in perpetuity, but we can assign the I minus minus, or minus minus I here. And that would kind of, instead of counting up like this does, it would actually count down. Okay, now while loops, okay, are similar to loops. They're similar in functionality, but they have different syntax. So here we have this for loop right here. For int equals 0, and we have the fact that the for loop will run until I is less than 7, and then we're going to increment by 1. So the loop kind of ends. So that's your for loop. But here is it restated as a while loop. We have int, let me push this up here, int I is equal to 0, and while I is less than 8, we're going to print hello world, and we're going to increment I by 1. Okay, so with a while loop, we have a point of reference right here, I equals 0. And then the while loop asks us that while this condition has been satisfied, it will run the things in here. It will run all the syntax here. So let's look at the concept of why even while loops. What a while loop is. A while loop repeats a block of code as long as the condition remains true. It's best used when you're not sure in advance how many times the loop will run. Examples include repeating until a condition is met. Okay, so for example, run logic until a goal or threshold is reached. So for example, you keep, whoa, hold on. 1 second, I just heard something weird at my house. 1 second. Okay, sorry about that. Anyways, so imagine, if you will, well, actually, repeating until a condition is met. Can somebody here give me an example? Eldon, Beatrice, Sabanti, somebody here give me an example where we can repeat. How about something
Um,
cybersecurity wise? What do you think? And just so you know, I'm not able to see any text right now. So what do you guys think?
I mean, I can't think of anything necessarily like cybersecurity wise, but like when going through a data structure or an array, you could like keep going until like while there's still something next, just to
Mm-hmm.
go through all elements.
Yeah.
I've done that before.
Yeah, yeah, that's good. That's good. The only thing that comes to my mind, and the only reason why I'm saying this is because I had the bullet already in the chamber, so I already had the example in my brain. But the maybe using, have you ever signed up for a service and they're like, this password has to have, like, let's say, a special character. So you could
Yeah,
say,
yeah, I see where you're going
yeah,
here.
yeah, yeah, yeah. Or something like that. Or you keep on going through a loop until, like, you press Q for quit or something. Okay. Um, or in the case that I mentioned, forcing correct user input before proceeding. Monitoring and polling systems. So here's the idea with this use case right here: continually checking a system state. So when you think about an operating system, even the operating system we're using right now to view me, it's an OS, but that is like a one continuous while loop, right? If you've ever done any video game programming, okay, like if you ever used Pygame or something. Has anybody ever used Pygame or live wires and things like that? Um, there's a good book using Pygame and live wires. You can make little 2D top down type games. There's a game you can make with pizzas being thrown at you and you have to catch them. It's kind of like hokey, entertaining stuff. But why do you think so? If you've ever programmed a video game, you know that you're gonna have to deal with the surface. So you have to bring up the surface first, and then you can program your sprites and everything. But there is a continuous while loop that is going on there. Can somebody tell me what that while loop would be? Well, in this case, the while loop is would come from the fact that if you don't have your surface as a continual loop, it will shut down. You want because the surface lives on top of your existing desktop, right? And it lives there because of the while loop. So the while loop will free. If you've ever done any programming with graphics at all, it doesn't even have to be Pygame per se. But there's a lot of Python and Java type user interface type tools. Like, for example, Java has Swift and all that. And we'll take a look at Swift later on in the semester. But I'm just saying the reason why the while loop lives there is because you always have to keep it going because it lives on top of your desktop. Because if you quit it, then the surface or the user interface literally disappears. Okay, another example: keep a game running over and over. Retry logic and fault tolerance. Here's counters, with dynamic conditions, security and monitoring applications. And what this is kind of like what I was saying before, event-driven programming. So using user action trigger and all that. So while an event has not occurred, wait or listen. So in other words, it's saying while this service has not been cut off, it will listen. So there's a lot of things in information technology and in networking that requires the service to always be on unless a user kills that service. So an example is a web server. A web server will listen on a particular a particular port. Usually it's port 180, or excuse me, it's port 80. So it will listen to that port until you tell it not to. And the reason why you always want it to be listening is because it has to respond to whatever request that it is trained to do, what it is meant to do. So if it's an HTTP server, it's meant to take web requests. If it's listening on port 23, it's meant to take telnet requests. Here's your base case right here of the while loop. Okay, so we have x equals 4. While x is greater than 0, system.out print x value. So what you're doing is you're printing the you're literally printing the string x value plus and then the value of x. So right now x would equal to 4 and then hello. So x equals 4, but as you can see, it indicates x minus equals 1. Okay, so the result, however, is an infinite loop. You see that? So I did this sometime before class, and it was an infinite loop. It was an infinite loop. Let's see. How about Cole or Justin? Why is this an infinite loop? You have int x equals 4 while x is greater than 0. It says x value hello. And then it says x minus equals 1. But yet this is the output. X value equals 4 hello. Keeps on repeating 4. But I have x minus equals 1. Why is this an infinite loop? Somebody tell me why they think it's an infinite loop. Why did this code, and this is the result of this code, and Java C is how I compile it. So I created vim limit.java, and then I created this code in my terminal, and then I saved it, and then I compiled it with this command, java c limit.java, and then I ran it here, java limit. Why did this code result in an infinite loop? Now, if Cole does, if Cole doesn't figure it out, can somebody else tell me why this resulted in an infinite loop?
Hello, can you hear me?
Yeah, I can hear you.
Is it because x is always greater than 0?
Right. Yeah. You got the logic, but do you see I do have x minus equals 1.
Is it because x minus equals 1 isn't in squiggly brackets?
Well, why do I need squiggly brackets? I mean, I have an indent right here.
Because it's more than one line.
Oh, man. I was hoping you wouldn't get it so quickly. Oh, man. Okay, yeah, exactly. Now, so the solution is quite easy. We just added brackets around the while loop, we just added brackets, I say for the while loop, but we just added the brackets around the statements that we actually want created. What is on this one, we didn't have any brackets, so what does it do? Remember I said you don't need brackets if it's only one line of code that the condition is. But because I have more than one line of code without brackets, it's going to presume that all it needs to do is list this. Thus, you have an infinite loop. Here, we have an x minus equals 1 within the brackets. Okay, so we now have the result that we want. X value 4, 3, 2, 1. Actually, would have been actually better if there was a space after hello right here to make it more elegant looking, I guess. So as it says, without the brackets, the JDK interprets only the first line, which takes x minus equal 1 limiting which takes the limiting variable x minus equals 1 out of scope. Another while loop challenge right here. We have scanner equals new scanner. Now here, like this is an example where we're kind of going back to the example where we're just using input validation, kind of. Okay, so we're saying we here in this example we're creating a new scanner object. Okay, from this command scanner equals new scanner system.in, and we're allowing the user to actually input, so string equals input. And we're saying while input does not equal quit, we're saying system.out print hello world, and then we're asking this person to input code, and then it's going to repeat what we wrote. And at the end, we have, I'm sorry if it's not obvious, I did this in Vim. So we have the opening bracket here, the closing bracket of the while loop here. Okay, we have this here, and we have the opening here, so it is taking all this in. And this is what we call the ending condition. So after the condition has been filled, which in this case all it is that it does not equal quit. So the second the condition you actually put quit in, it should just say finished. But wait a second. We ran the code and it said hello world, and then as I put HAL, and I frequently put in the word HAL after after the movie based on HAL. What is it? A Space Odyssey, 2001: A Space Odyssey. Stanley Kubrick's was one of his first movies, so I do recommend everyone to see it. So Hal is a very, very, very famous character in that movie. So anyways, I wrote Hal, and the system responded to me saying, you wrote Hal. And then it said, hello world, and I put S, and you wrote S. And then it said, hello world, and then I typed quit, and then it said, you wrote quit, then it continues to say, hello world. And then I wrote quit, and then it won't quit. Even though this says quit, why is this an infinite loop? Somebody want to tell me? I mean, the brackets are here. There's brackets. There's an opening bracket after the while loop condition and a closing bracket here. And there's enough brackets to go around. There's brackets everywhere. So why is this an infinite loop? Somebody tell me. Okay. All right. So that's correct. We cannot compare strings meaningfully. Does everyone know why? The reason? Yeah.
Because it's going to show the memory location. So it's comparing the memory location of these two things. Or it's comparing the memory location of input to quit.
Absolutely. Absolutely. So the solution is to utilize the dot equals. Since it's a string, we can use the dot equals method to actually compare the actual literal meaning, the literal portion of the variable. So here, we run the program again after recompile it, after we utilize the dot equals method. We say hello world, we respond with HAL. It says you wrote HAL. It then responds with hello world again. I write gas. It says you wrote gas. It says hello world quit, and then it says hello world again. And I wrote quit, and then it says you wrote quit, and then it ends the while loop because we're able to use the dot equals method. And you can see here it says we have input equals an empty string, and then what we're saying is input equals, while it does not equal quit, it's going through this entire syntax. It's going to print hello world. It's going to wait for our input, and then we'll print you wrote, concatenating with our input. And again, it's the same thing here. This won't work because we can't compare the actual values of string, because string is an object, and objects compare the actual memory locations, not the values themselves, unlike primitives. And here we extend my prior example even further. Here, if I actually type in caps print, it will input the lowercase version of it. So scan.next input equals scan.next dot lowercase. So that's what we call method chaining. Scanner.next, and then that is chained to dot lowercase. So this is good. Two lowercase is a good method to employ if you're storing, names and things like that in a database. This way, you're making sure that everything is lowercase, because when somebody types in answers to questions, they at times type it in uppercase and lowercase, especially proper names. And for storage purposes, sometimes you don't want that. You want everything in lowercase. So method chaining is a good way to do that. What a method chain is when you add more than one methods in one line. So input equals scanner. Now scanner, of course, it relates to the object name scanner. And in this case, an object is a variable. An object is a variable when the variable uses a reference variable as its type. Okay, a variable is a primitive when it uses a primitive variable as its type. So scanner, type scanner. Okay, and because we're using scanner as type scanner as the class, we have access to all the methods that were created when whoever it was created the scanner class. One of the methods is .next, in which it is accepting input from the user, and then it gets chained, if you will, or it gets linked to yet another method, .to lowercase, in which if the user happens to add some caps or uppercase to whatever he's typing in, it will then make sure it winds up being all lowercase, and then that is what it will store, or in this case, that is what it will print out. Now we have the concept of do while loops. Now they are rarely used. They are similar to while loops, but it gets executed at least once. Okay, in this particular case, we have, in this case, the traditional while loop. We have while input does not equal quit. It will constantly ask for input, and it will present to us like a cursor or something for us to input in lowercase. So in other words, the .to lowercase is a method chain, which allows us to put in upper cases, but it will it will produce the lowercase. That's what it will store, and then it will print. So what's actually going on is that it checks the condition first. So if the condition is false, this loop will never ever get executed. So for example, if input equals quit, then it won't get ever see the light of day. Whereas here, we do execute this, and so at least once the user will see the input and allow us to kind of like input whatever we want to type in. Okay, but if the user does press quit, it will naturally quit. So even if the condition is false at first, the loop will get executed at least once. Now, as we said, it's rarely used, so I just wanted to introduce it to everyone, in case, in fact, you did want to ever use it. And I could see its use. I honestly could. It's rarely used. Now here we have the break and continue statements. Okay, so we usually issue this with a while loop. Okay, we see the quit word printed. Okay, so we have scanner equals new scanner, string equals input, while input does not equal quit. Okay, we can see that it will print quit. So here the input is quit, and it actually prints quit. Okay, and as we say, it looks kind of I use the word janky. I apologize. I use the word janky just to get you as an example. Here, we'll say new scanner in string equals input. Okay, and we'll say while input equals quit. Well, while input does not equal quit. Okay. And we'll say input scanner next dot to lowercase if dot input equals quit system dot print out line input, meaning it does not print quit afterwards. It just works. Here we can do the same thing using the break command. So we say if input equals quit, we simply break. Okay, so that kind of satisfies this right here, in which when we type quit, we don't want it just to print out quit, and it will do the trick. It will break out of the while loop, which is what we want, but it looks kind of weird just to say quit. It doesn't look professional. Now, this actually accomplishes the same thing, but here, this is really the optimal way because we're using the break command, which is yet another key word. And the reason why the break command was put in place was simply to avoid this jankiness right here, where the user types in quit to get out of the while loop, and the system still prints out quit per our programming. But here it's much better if we use the break command. We say if input does equal quit, okay, we will simply break out of the while loop, which is what we want anyways. Okay, and here we are using the continue command. Okay, so while input does not equal quit, system out print input. Okay, we use the method chaining scanner.next to lower class. We'll say if input equals pass, we'll continue. However, if it equals quit, we will simply break out of the while loop. Okay, and if we don't do that, then it will just simply print the output. So as you can see, break quits the loop, and continue moves back to the beginning. Okay, and a common technique from programmers is such that we'll do if input equals pass, we'll continue. if it equals quit, we'll break, and then we'll just simply keep on printing out the input from the user. So this is kind of like best practices right here. Okay, now we only have 3 more slides, which is good. Now this is a for each loop. Now the for each loop is when we actually have a row of arrays and we want to step through the array one at a time. Okay, so we have fruits is equal to blackberries, grapes, and strawberries, and we say for I int equals a, and then we have the ending condition, I is less than fruits dot length, okay, and then we kind of like have an increment of going one at a time. But look where the ending condition is. The ending condition is determined by whatever the length of the array is. So we can have 10 things in here. We can have blackberries, grapes, strawberries, blueberries, watermelon, peaches. Okay? We can have red grapes, green grapes. We can have tomatoes, cucumbers, anything in there. But as no matter how many elements in this array that we have, the for loop knows to increment one right after the other until it stops at the length of the array. So that's why there's some automation built in this. You can have the user, imagine, if you had an array, let's say you combine this array with something that said, hey, you're going to define this array, and you're going to keep defining the array until you've reached the, let's say, the length of the array, and then you're going to iterate over it with the for each loop based on the length of the array. Okay, and then you can just print out, you can iterate through the array by printing each item in the array. So this one says for I starts at 0 until the amount of the array gets into the length of all the items in the array. Okay, you're going to iterate it one at a time. So you're going to go to fruits, and then if I is equal to 0, you're going to say fruits, blackberries. And then you're going to iterate it one at a time. So you're going to go fruits, and then I plus 1, which is grapes, and then I plus 2, which is strawberries. That is what we call the for each loop. And we can do the same thing here as in reverse. If we said I equals fruits dot length, that's where we start, which is I is equal to 3. And why is the minus 1 there? Can somebody tell me what the minus 1 is?
It's to make sure it doesn't go out of bounds because arrays start from 0. So
Absolutely, yes. And then we're going until we're starting at the end, and we're going until I is greater than or equal to 1, and then we're going in increments of negative. So we're going strawberries, grapes, and blackberries. And this is the last slide, okay? For each, it might be might be a little bit less messy, a little bit less messy method. Here we have fruits is blackberries, grapes, and strawberries, and then we're saying for string fruit and fruits, system out, print line fruit. And really, I should have done it like this. I should have said for I colon fruits, and then we should have said print line I. Would have been the same thing. And maybe it would have been easier to read. But you can see what's going on here. This is kind of like shorthand for this. Or actually shorthand for this. I equals 0, I less than fruits.length. So this is like an automated, this is like the newer way of doing the for loop. String I colon fruits system dot print line I, where I is the iterator, and this defines what we're iterating over. Okay. Was there any questions? Okay, if there's no questions, I'm going to end it here, and then I have an in-class assignment due in 48 hours. Okay, now if there's no questions, then I'm just going to end it here, and I will say thank you very much for joining me today. You're getting some time back, but you are to work on your in-class assignment. And it is already uploaded.
Have a nice rest of your day.
Okay, thank you very much. Bye-bye, everyone.